The last section to this lesson is on the difference quotient. The difference quotient is used to understand the rate at which functions change, which is covered heavily in future courses. For this college algebra course, we will need to understand how to evaluate this ratio, not necessarily understand so much what it means, which will be covered heavily in future courses. We want you to be prepared algebraically so that you can understand it when you cover this again. The definition of the difference quotient is f of x plus h minus f of x all divided by h, where h cannot be equal to 0 because then otherwise it would not be defined. We're going to take different functions and try to evaluate the difference quotient for each of these functions. Students often have a hard time with the f of x plus h part of the difference quotient. So before I do each problem, I'm going to come over to the side of the problem and evaluate f of x plus h before we actually do the entire difference quotient. For this particular problem, f of x is equal to 6x plus 1. I'm replacing every time I see an x with an x plus h. When I distribute this, I'm getting 6x plus 6h plus 1. When I evaluate my difference quotient, and I'm trying to find f of x plus h, I'm just going to take this red answer that I've gotten, 6x plus 6h plus 1, and then I'm going to subtract f of x. And the f of x that I have here is 6x plus 1. I put this in parentheses because I want to subtract the entire function, and I'm going to have to distribute. Lastly, I have this whole function divided by h. Next, I'd like to simplify the numerator by distributing the negative 1. Combine like terms. The 6x minus 6x adds to 0. The 1 minus 1 adds to 0. And I'm left with 6h divided by h, which reduces to 6. Therefore, the difference quotient for the function f of x equals 6x plus 1 is equal to 6. My next function, f of x equals negative 2x squared plus x plus 5, I'm still trying to find the difference quotient. I'm still using the same definition given above. First, I'd like to come off to the side and make sure that I understand f of x plus h for my new function. For my new function, I'm having negative 2 x plus h squared in place of x plus x plus h, which is in place of x, plus 5. This one's going to take me just a little bit of time to distribute before I actually go back and put it into my function. Don't forget, when you square a binomial, you either have to have your formula memorized or you have to write it twice and double distribute. Getting x squared plus xh plus xh plus h squared. Then I'm going to distribute my negative 2 all the way through. And lastly, I can combine these two like terms to get negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5. Just rewrote my difference quotient here so you can see it. The f of x plus h is that red distributed problem that we worked onto the side of our paper. Then it says minus f of x, so I'm going to subtract and in parentheses write my f of x. And that whole thing is going to be divided by h. I'd like to distribute my negative 1 all the way through to get plus 2x squared minus x minus 5. At this point, there should be a lot of canceling. Just in our first example, as 6x and minus 6x canceled, the plus 1 minus 1 canceled or added to 0, there should be a lot of terms that cancel here. Minus 2x squared plus 2x squared. Plus x minus x adds to 0. Plus 5 minus 5 adds to 0. Notice that the entire green terms, all of the minus f of x, all canceled out. And that same thing happened up here. All of the green f of x terms canceled out with the f of x plus h terms. And that should happen every single time. What do I have left? I have negative 4xh minus 2h squared plus h all divided by h. Notice that every term in the numerator has a common factor of h. And that should happen every single time. In order to get this h to cancel, just like the h's canceled in the first problem, in order to get the h's to cancel in the second problem, I'm going to factor out an h out of the numerator. And then the h in the denominator and the h that's factored out of the numerator divides out to 1, and my difference quotient is negative 4x minus 2h plus 1 as my final difference quotient. On our last problem, we have f of x equals 1 over 2x. For my f of x plus h part, I'm going to do that part off to the side here. I have 1 over 2 times parentheses x plus h. Now, we could distribute this out, but because it's a denominator and I might have to get a common denominator later, I'm going to just go ahead and leave it like that. If eventually I'd like to distribute it, I can, but for now I'm going to leave it just like that. So my red f of x plus h is 1 over 2x plus h minus my f of x. And my f of x in this case is 1 over 2x. Because it's one term, I don't need parentheses around it. All divided by h. Now I said that everything canceled out in the green, correct? Well, in this case we don't have a common denominator, so it's not very easy to see if it's going to cancel out or not. So I need to get myself a common denominator. And the common denominator between 2x plus h and 2x is 2x x plus h, all the unique factors. In the first denominator, it looks like I'm missing an x, so I'm going to multiply an x to the denominator and into the numerator. In the second denominator, it looks like I'm missing an x plus h, so I'm going to multiply the x plus h to the numerator and the denominator, which leaves me with x plus h. Now those parentheses are still there because I need to subtract the entire numerator. So I have x minus h over 2x x plus h, but don't forget that this whole thing is still being divided by that black h down there. When I add or combine like terms in my numerator, the minus x and the plus x cancel out, and I did get rid of the x terms and just leaving my h terms. So I have negative h over 2x x plus h, still all divided by that black h. Well, in order to divide two fractions, we're going to multiply by the reciprocal, so I have negative h over 2x x plus h. And instead of dividing it by h, or h over 1, I'm going to be multiplying it by 1 over h. Notice that the h in the numerator and the h in the denominator divided out, just like they did on the previous two examples where the h in the numerator and that h in the denominator should always divide out. My resulting difference quotient is negative 1 over 2x x plus h. And that concludes our section on more of the basics of functions and their graphs. Again, we covered odd and even functions and their symmetry, piecewise defunctions, evaluating, and graphing piecewise defunctions, and we finally finished with difference quotient.